Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this session I'm working on hypothesis testing and regression analysis. So simply we have two variables. One is our independent variables, which is exports, and another is dependent variable, which is GDP. So I'm just exploring the relationship between these two variables. In both of them, they are in billion dollar. So simply first, dear students, you should have your null hypothesis, and that is our H naught. And so I just state that there is no relationship between exports and GDP. And our alternative hypothesis, which is A1, then H1, there is, you can say, uh, positive positive relationship between exports and GDP, dear students. Very much simply, the first one we call it the null hypothesis, right? And this is our alternative hypothesis. So the concept behind your students, you should know that the model here is that the GDP we say that equals to beta naught, right? And plus we have beta 1 and x. This is the deterministic model. You can say the x is here, the export is simply there's an export. Okay. Okay, dear students, this is our dependent variable and export is our independent variables. Now I'm just exploring the relationship between these two variables. So keep in mind this beta 1, this is the coefficient of exports. So if the beta 1 is 0, it means there is no relationship. And if the beta 1 is greater than 0, it means there is positive relationship. And if it is less than 0, it means there is negative relationship. So in our null hypothesis, we just assume that the beta 1 that equals 0. And in our alternative hypothesis, I just claim that the beta 1 is greater than 0, students. Okay. So if it's greater than 0, it means there is positive relationship. But in hypothesis testing, I should check whether it is significantly different than 0 or not. So for this purpose, I'm just using Excel, right? And I'm just giving you the concept of hypothesis testing. So we have in data, we have data analysis, dear students. And here just we have regression simply. And just take your y variable, this is our y variable, and then just take your x variable simply. Okay, dear students, just include the labels, why we have labels, and then the confidence interval is 95%. This is really important. The confidence interval for my analysis, that is 95%. So the alpha significance level is 0.05. So if the p-value is less than 0.05, we are rejecting the null hypothesis. So the output range, I'm just interested to just show me here. Okay, this one's okay. This is the output of the hypothesis. Dear students, look here. The alpha, I'm just interested in the alpha, that is 0.05. So in this output, dear students, the elements or information which is very much important for you just to check is the first one is r square, right? Simply just check how much variation is just explained by the regression model simply. And now this is the intercept here, okay? And this is the coefficient. So simply these two informations that they are very much important, right? Okay, dear students, so simply you can say the intercept or the beta 1 in the beta naught in our analysis here, that is 87.115. In the intercept we have, that is exports, you can say beta 1, that is 4.598, dear students. Very much simple. So first you should learn what is the interpretations of 4.598. So simply you can say for as the unit is here the billion dollar USD, so you can say for the interpretation of beta 1, you can say for every 1 billion USD increase in exports, the GDP is expected to increase, right, by 4.59 billion USD dollar USD simply. This is the interpretation. Okay, for every unit here you can say, dear students, for every unit, for every billion USD increase in exports, the GDP is expected to increase by 4.59 billion USD, dear students. This is very much simple. Okay, now what is the interpretation of intercept, which is beta naught 87.11? So simply you can say, when exports are zero, simply the GDP is expected to be how much? 80, you can say 87.115 billion USD, dear students. Okay. Okay, now since the beta one is 4.598, so it's mean there is positive relationship and the interpretation is clear. But keep in mind whether this relationship is significant or not. You should just check the p-value. This is our p-value response. Okay, now this 1.4, this can be written like this: 0.000045678, and then you should write 1 4 in this way, right? So this value is, okay, once again, just let me show you. This is just a value, right? So the p-value, dear student, that's way less than 0.05, which is the significance alpha 0.05. So we are rejecting the null hypothesis. Okay, so what is the interpretation of this p-value? So you can say, dear students, since the p-value, which is in this situation 0.00000, right, 14, right, this is less than, yeah, you can say this is less than 0.05, right? Then you can say we reject the null hypothesis and conclude that the coefficient of 4 is statistically significant, dear students. Okay, it means the effect of this coefficient, which is 4.598, the change in x, that is just affecting the dependent variable, which is 4.598 billion dollars, and this relationship is significant since the p-value is less than 0.05, dear students. Hopefully the concept and idea is clear. But this was, dear students, just have to find out the p-value in the coefficient intercept in the r-square directly using the output of Excel. Okay, dear students, have to find out the beta 1 and beta 0 manually. This is a method I have already explained, right? And have to find out the beta naught. This is already clear. But one point here, dear students, that is t value. So in manual steps, when you just do it manually, so first you should find out the beta 1, right? And then you should convert the beta 1 into the t statistic. You should standardize it, convert it into the standard unit, which is the value of t statistic, or you can say sample t statistic. And then you should just find out the critical value and then compare it, whether the t statistic is lower or greater than the critical value, or you can find out its probability from the t table. Okay, how to do that? First, you should know what is the t statistic here. So the formula for the t statistic, simply t statistics we have, that equals to, we say simply the beta 1, right? The beta 1 should be divided by the standard error of the beta 1. This is the function, dear students, just simply computing this t statistic. If you are not using the output here and just directly in manually finding out, so first you should have your the model, and in this model you should find out your beta 1 and beta naught, you know how to find them out, and then you should standardize your beta 1, convert it into the t statistic, and then you should check the critical value. Okay, simply from this output you can find out the t statistic in this way. Okay, since the t statistic is having two elements, which is beta 1 and the beta 1, we found out this is 4.5, and then we have the standard error of beta 1. This is the standard error of beta 1, dear students. So simply just equal sign in this beta 1, which is, this is the beta 1, should be divided by the standard error, and this is just giving you the value of 3.55, dear students. So look, the t statistic value already given, which is 3.556. Okay, when you find out the t statistic using the function of the t statistic, right, And then you should compare this 30.55 with the critical value, right? This is another way of just testing the hypothesis. So have to know what is the critical value of the t statistic for the t value here. So keep in mind, in t statistic you should know what is the degree of freedom. So the degree of freedom we have, that is 8. Why? Because the degree of freedom in case of regression analysis, you should subtract the coefficients. We have beta naught and beta 1, and that's two coefficients we have. So n minus 2, that is equal to 8, right? This is the degree of freedom. And the next is the significance level. So for the degree of freedom 8 and significance level of 0.05, you can find out what is the critical value. So look, dear students, for the degree of freedom of 8 and the significance level of 0.05, we have the critical value is 1.860. So you can say the critical value in this situation, that is 1 point, that is 1.860 students. Okay, now this is another method, dear students. If you're not using this output, so you should find out the t statistic, right? And then you should have the degree of freedom and the critical value, right? Now you should, okay, the degree of freedom and the alpha is just helping you to find out the critical value. And then you should compare your t statistic with the critical value. In this situation, you can say what is the interpretations, since the t statistic value, which is 30.5568, is greater than, simply you can say that is greater than what, greater than the, the critical value, which is 1.860 returns. So we reject the null hypothesis at 5%, right? Simply a 5% significance level. Okay, this is another video, students. Once again, the straightforward method just to find out the output, and this is just the concept behind. If you just use this method, it's also correct. Okay, once again, you should find out the beta 1 and you should standardize it using the t statistic method, right? And then you should have the degree of freedom. For the degree of freedom 8 and the alpha of 0.05, you just go into the table and just find out what is the critical value, and then this critical value should be compared with the t statistic. So what does this really mean, dear students? Okay, practically, if I just draw the normal distribution like this is, dear students, look, this is the line. Okay, sorry for this. It's not good. Okay, if you just draw the line here. Okay, look, dear students, this is the, it's not perfect, but anyhow, I'm just trying. Okay, so this is the normal distributions. So you can say this is the area where I'm just rejecting. This is the significance level, which is simply you can say 0.05. Okay, and here you can say the hypothesized beta 1, right? The beta 1 value, this is equal to 0 in this point, right? Simply. And what is the critical value? This is the point of the critical value. So the critical value here is 1 point, simply 1.86, right? Okay. So now the t statistic we found, that is 30.55. So we can say this is above the critical value. The critical value 1.86. This is the boundary. So it's above the critical value. It means it's the under the p value of 0.05 cumulative probability. That's why you can say you can reject the null hypothesis. So this is another methods of rejecting the null hypothesis. This is just the concept behind it. So hopefully the idea is clear. Now I'm just explaining furthermore how to find out the t statistic value, right? Why? Because for the t statistic value directly I have just used the beta 1 and the standard deviation of beta 1. Okay, simply I just have taken this from this output. But what is its function? How to use the function manually? What is the steps you should use for the t statistics? Look here. Okay, dear students, I'm just doing all these steps manually. So this is the function of the t statistic where you should divide the beta 1 should be divided by the standard error of beta 1. Okay, so have to do that first. So first you should compute this, right? This first step, and the second, and this way finally we are just computing the t statistic. So for the first step to compute the beta 1, dear students, you need x minus x bar. Okay, simply we need here x minus x bar, and first you should compute the x bar value, and this is the average value. You should take the x bar. Okay, and also this is the y bar. So simply this is the average of y bar. This is the y value simply. Okay, this is, dear students, you can say this is the x or y bar simply. Okay, these are the averages. Now for x minus x bar, simply from each x value you should subtract the x bar. This is very simple, dear students. Just drag it down. And then the second step is the y minus y bar. Look, dear students, I'm just doing it practically for you. This portion is just clear. We have just computed this one. Okay, in this way you should continuously find out other. Okay, now we have the y minus y bar. Y minus y bar simply. So from each y value you should subtract the y bar. This is y bar. Okay, just drag it down simply. Okay, next you should, okay, this is the second step we just found, this one. This is also clear. Now you should take the product of both of these values. Okay, have to take the product. Simply you can say the x minus x bar should be multiplied into y minus y bar. Okay, and this value should be multiplied with this one, and just drag it down. So the multiplication is also clear, dear students. Okay, just I'm moving. Okay, next, dear students, okay, just let's make it a little bit smaller. Okay. You need x minus x bar square. Okay, so just take the x minus x bar square, x minus x bar square simply. So first we have x minus x bar, but this is x minus x bar, and the x minus x bar square is missing. Just equal sign, and just click on this, multiply it with itself simply. This is the x minus x bar square. So these are two important elements or informations we have at hand now, which one is the numerator, another is in the denominator. Just take its summation. Okay, this is the summation of one, and this is the summation of another. Now we found out beta 1. Simply the beta 1 here is equal sign, and this the sum of the product of both of these variables here just should be divided by the denominator, which is summation x minus x square, and this is the value. So this is the beta 1. Simply in the previous example you have just learned how to find it out, but here I'm just doing all these steps manually, dear students. Okay, and what is the beta naught? For the beta naught, simply, dear students, we have the function, right? The y bar equal sign, this is the y bar, right, and minus the beta 1, this is what we have computed, should be multiplied with the x bar, dear students. So this is our y bar. Okay, once these two elements are clear and you just computed both beta naught and beta 1, then, dear students, we can find out the other informations we have. Okay, up to this point is clear. Next we need to find out this, which is the standard deviations. So the standard deviation which is used here for the standard error of beta 1, we need the s should be divided by the square root of summation x minus x bar. So this s is actually the standard deviation, but this is the standard deviations of the error, dear students. Okay, so from y actual we minus y hat and raised to the power 2. So this is the standard deviations of error. So for this, dear students, we have y actual minus y hat. Okay, so how to find out the y hat? The function of y hat, simply, dear students, that equals to, we have beta naught, right, beta naught, and then plus we have beta 1, and, dear students, we have x. So the y hat, dear students, this is our GDP. We just try to find out the y hat, estimated y hat. So here is the beta naught, and this is beta 1, and we have the exports. So simply for y hat, just follow the order we have in this equation. So first equal sign, just take the beta naught, this is the value of beta naught, and plus then we have the value of beta 1, and this should be multiplied with each value of x. This is x simply dear students. So now this is the column for y hat. So we found out y hat. Okay, once just when you just choose these value dear students, when you click on this value, just click on the F4. Okay, this is really important. Okay, this is the first value, and just press F4 and click on this value F4 value. Stick into the reference cell. Just drag it down a bit. So this is y hat. So we need y minus y hat, dear students. So simply y minus y hat. Okay. For your students, equal sign. This is our actual y value, and you should minus the y hat. And this is just giving you the error. Simply, this is the error. Okay. Now this error should be squared. Simply just take this value and square it, dear students. Okay. Now equal sign. This value should be multiplied with itself, or you can just raise it to power 2. You can use the function of power. Now we just found out the y minus y hat square, right? And then dear students, you should find out its summation, right? So I'm just summing it up. This is its summation. And next dear students, the summation should be divided by n minus 2 the degree of freedom. Okay, so it means if you just divide this value by degree of freedom, or simply if you just try to find out the standard deviation or the standard error using this function, right? Simply, very much easy, equal sign, and the equal sign, just take the square root. So we are just taking the square root of what? The square root of this value, right? And this should be divided by n minus 2, which is 8, the degree of freedom response. Okay, this is the standard error. Simply, once again, I'm just repeating, just take the square root. Why? Because this is the square root of the summation y minus y hat square, which is this value, and this should be divided by n minus 2 degree of freedom. Okay, so we found out the standard deviation here. Okay, now dear student, for standard error you should divide this value. So this is, now we just try to find out the standard error, which for beta 1 simply, and that is just equal sign, this standard deviation should be divided by the square root. Just take the square root of x minus x bar square, and the x minus x bar square value is simply, this is just the x minus x bar square, some value, this one, right? X minus x bar, this is x minus x bar as equal to, and just take its summation. I have just taken its summation in the square root, as it is just clear. Okay, dear students, so this is, dear students, the standard error. Now you can find out the t value. So the t value, or you can say the t statistic, dear students, this is simply, okay, just make it in the center. The t statistic, dear students, equal sign, the beta 1 should be divided. So this is our beta 1, dear students. This should be divided by the standard error of beta 1. This is the standard error of beta 1, dear students. So the final answer is 30, and this is exactly where we have the 30.55, dear students. Okay, so now you know what is the critical value, dear students, and that is 1.86. Okay, look, dear students, we already found out what is the critical value, and that is 1.86. Now you just simply say 1.86. You just simply say that since the t value is greater than 1.86, right, the critical value 1.6 is, we are rejecting the null hypothesis. Why? Because it's above the confidence interval, or you can say the p value is less than 0.05. Hopefully the idea of the test statistic is clear. Have to compute the test statistic, so you should use these steps manually, students. Assalamu alaikum wa rahmatullahi wa barakatuh.